So it's possible to integrate ln x to the power 2 using substitution. We actually use a combination of substitution and integration by parts. So if we were to choose ln x as our u, we know how to differentiate that. So that looks like a good place to start. So we can say du by dx, the derivative of ln is 1 over x. We can rewrite that to say dx equals x du, and then we can replace that instead of dx in the original integration. So our integral will now look something like this. The integral of u squared multiplied by x du. That's still not ready to integrate because we have this x term. So we need to somehow get rid of the x, or rewrite x in terms of u. So looking at this, u equals ln x, we can rewrite that as x equals e to the power u. So that's just how we invert a log. And then we can use this new expression for x in terms of u in our integral there. So I can now write this as the integral of u squared multiplied by e to the power u du. And now, at least now we've got rid of the x. Now we only have u's, and it's reasonably straightforward to integrate. We would probably need integration by parts, and we would need it twice actually, because we have u to the power 2. So let's integrate by parts. So we would take u in this case as, well, I think it's bad choice of letters, but I'll call it u, and we would take that to be the u squared, so that when you differentiate it, you get 2u. So our dv would be e to the power u, and the integral of that is simply e to the power u. So using integral or integration by parts, we now know that the integral of u squared e to the u du equals u squared e to the u minus the integration of 2u e to the u du. And once again, we're going to have to do integration by parts to find this. So it's integration by parts again. So if we choose u, dv, du, and v, we would choose 2u as our u, that differentiates to 2, and e to u integrates to e to the power u. So again, apply the integration by parts formula, and you end up with, just for this part, you end up with u times e to the power u minus the integral of 2 e to the power u du. Now remember, this is all part of this larger expression, so we should really write it out like that. And because all of this is contained within our integration by parts, so we should have brackets there. Now, the integration of 2e to the power u is simply 2e to the power u, so I can now write my final answer as u squared e to the power u minus 2u e to the power u minus, the minus with the minus becomes plus 2e to the power u plus c. And I can simplify that by taking e to the power u as a common factor. Now I have u squared minus 2u plus 2 plus c. And our final step, I think, will be to replace every instance of u with ln x. So u, remember, is ln x. So that goes into there, and there, and there. So we can write it as e to the power ln x times ln squared x minus 2 ln x plus 2. Now, e to the power ln x is simply x, because the exponential is the inverse of the log function. So that becomes simply squared x minus 2 ln x plus 2. So that's your final answer for the integral of ln squared x dx. So we did that using substitution and integration by parts. We could probably have done this using integration by parts 3 times, or twice maybe, without using substitution.